Hello, and thank you for joining me. Today's presentation will showcase the results of three simple regression tests that I conducted. The agenda for this presentation is as follows. First, I will discuss the objectives. Then, I will cover all three of the regression tests. Following that, I will discuss the takeaways from the tests. Then, I will discuss the three annotated bibliographies that helped me throughout this course. Following that, I will open the floor to discussions. And lastly, my references. For the next few minutes, we will be looking at my results for the three regression analysis tests, which was designed for the purpose of examining the relationship between two or more variables of interest. In other words, the objective for this test is to see whether or not these variables have impacted an individual's financial status, and if so, to what extent. The first regression test was debt and income. The following regression was conducted. The null hypothesis states the regression coefficient is 0. The alternative hypothesis states the regression coefficient is not 0. A simple linear regression was conducted to determine whether an individual's debt could be predicted when compared to their income. Based on this, no significant regression was found. Beta equaled negative 0.05, r squared equaled 0.00, p equaled 0.535. The second regression test was savings and income. The following regression was conducted. The null hypothesis was the regression coefficient is 0. The alternative hypothesis was the regression coefficient is not 0. A simple linear regression was conducted to determine whether a person's savings could be predicted from their income. A statistically significant regression emerged. Beta equaled negative 0.91, r squared equaled 0.82, and p equaled 0.0. Thus, the test rejected the null hypothesis and predicted regression with the passivity scores. Savings equaled 0.91 times income minus 203.47. Savings is predicted to increase as income increases. Further, the 95% CI, which was 0.91 and 0.11, does not contain 0, hence lending support to the prediction. The third regression test was stocks and savings. The following regression was conducted. The null hypothesis was the regression coefficient is 0. The alternative hypothesis was the regression coefficient is not 0. A simple linear regression was conducted to determine whether a person's stocks could be predicted from their savings. A statistically significant regression emerged. Beta equaled negative 0.28, r squared equaled 0.07, and p equaled 0.0. Thus, the test rejected the null hypothesis and predicted the regression with the passivity scores of stocks equaled 0.28 times savings minus 1006.73. Stocks is predicted to decrease as income increases. Further, the 95% CI, which was 0.07 and 0.25, does not contain 0, hence lending support to the prediction. And now it's time for the takeaways. The first one is the objectives. The objective for the test is to determine whether or not the variables have impacted a person's finances, and if so, to what extent. The standard deviation, which is a calculation utilized to indicate the extent of deviation for a group. Linear regression, which is an approach to modeling the relationship between a dependent variable and one or more independent variables. CI, or confidence interval range. A 95% confidence interval is a range of values that you can be 95% certain contains the true mean of the population. And the results from the test. Out of the 3 tests, savings and income, as well as stocks and income, had significant results. Lastly, we were asked to describe the 3 resources that truly helped us out throughout this course. So in the next few slides, I have created an annotated bibliography to illustrate the sources I found truly helpful to me. The first one was the Understanding Null Hypothesis Testing by the University of Minnesota. This resource in particular provided an overview on a null and alternative hypothesis, defined the reasoning behind accepting or ejecting a null hypothesis. It described the p-value and how it fits into the null hypothesis testing. And lastly, it gave me the criteria for statistically significant tests. The next resource was the chi-squared contingency tables by D.M. Lane. This resource in particular outlined how to utilize the chi-square test, defined the steps required to solve significant relationships, gave me a chi-squared formula, and also gave an example of a chi-square test in which the reader was able to walk through the beginning phases for accumulating the data, testing it, and then translating the results. The last resource that I found very helpful was the 5 guidelines for using p-values by the Minitab blog editor. This resource in particular taught me how to interpret the p-value, taught me that statistically significant results does not always translate to something in the positive world, as well as past data has proven that the alternative hypothesis greatly affects the false positive rate, and in these types of tests, the subject area knowledge truly matters. So now let us sum this all up. But I would like to illustrate a quote by Dr. Seuss first. The more that you read, the more things you will know. The more that you learn, the more places you will go. I felt like this quote is near and dear to me because when I started, I had a zero background in anything quantitative research, which caused me to have minimal knowledge. On top of that, the knowledge that I did know was poor due to past classes I have had. And to top everything off, my math was very weak. But this is just in the beginning of this class. In the end, I found numerous things that I could take away, which is an understanding of quantitative research. I found an unknown interest in conducting these tests. I now know the tools that are utilized in these tests, and I have resources I could go back to refresh my memory or if I have other questions. And that concludes my presentation. So I'll now open the floor to any questions. And if there are no questions, I would like to thank you for your time.